Hello and welcome to my Nintendo Wii programming video. So this is video 3. You will need to have seen video 2 to understand how we are getting the 2D set up in this video, as it is a continuation from the last video. So what am I going to talk about today? So I will go over the scrolling effect that I've created in the demo program as it is at the moment. I will show you how I created the sine wave effect for the enemies moving, and I will then go over the baddie manager code and show you how that works and how the baddies check for collisions with the player. I'll then go over the explosion manager, and then I'll go into detail of what you can expect in the second part of this video, as it will be a two-part video. So first off, let's open the Dolphin emulator and have a look at our project. So here's our player. It's a control Wario, and you can't die at the moment. The player collisions aren't actually in. The player plane has a number of bullets that he can fire, and you can see explosions occurring when the bullets hit the enemies. Probably too many bullets at the moment for the player, but you can see that everything is in place to be a game at this time. Not sure what I'm going to do with Bonsai Bill here. There is like a sine wave movement set up for both Bullet Bill. He's using the same sort of sine wave setup as the Cooper wave here. And you can see the clouds here. There's like two layers. There's if I move into the clouds, you'll see there's some which are below the character, and then there's others which are above. Gives the effect of translucency in the clouds. And then we have a life icon here, and this tells us how many of the Cooper wave are on screen at any one time. So now I will stop that. So first off, let's have a look at the sprite sheet which I will be supplying with this project. So there are some custom coin graphics here. I'm not sure what exactly I plan to do with these. It could be that when you destroy one of these, they'll drop a coin that you can collect to get extra score. I was thinking about maybe putting in some sort of towers to avoid. It might be a bit too much to sort of pack into one video. I don't know. And then some custom explosion frames here. And then you can see our Coopers here. The plan with these was maybe if there was going to be like a ceiling and a floor layer, maybe they could sort of run on the screen on the floor, maybe sort of shoot bullets at you diagonally or something. Maybe I'll implement that, I'm not sure yet. And then we have like a custom font set here. and then we have 2 frames of our Wario plane animating here, and then another 2 frames for when he is either hit by a bullet or maybe collides with one of the enemies here. This here is our bullet, and then this is going to be the bullets that the penguins and Koopas will fire. And then at the bottom here, this was a last minute addition here. There are some clouds, 2 clouds here, and you can see that the alpha value here is set up for translucency. So if you look in here, this channel at the bottom here is the alpha channel. So if this is less than 255, then it means that there is semi-transparency baked into that color. So both of the clouds have that. So that is all the potential actors in here for now. So if I open up the initial project, the background layer was something different. So the background layer itself, I sort of drew some clouds on, and I had 2 of these images which I was drawing right next to each other. So you would have like one of these, and then you would draw the next one right next to it, and then move both of them around, and then once one of these images dropped off the display, it would then move to the back. And that all appeared to work fine on the Dolphin emulator. Thankfully this morning I tested everything on my Wii, and that was when I saw that it was glitching out. Good job I sort of tested it on the Wii, and that's a reminder whenever you are coding on these consoles, is to always test it on the real machine, which is why I tend not to, or I won't be making any videos going into any detail on machines that I don't own, because emulators aren't actually that accurate. They're there to reproduce the games on the desktop any way that they can. At the end of the day, playing a game from a console on your desktop or on your mobile, it's more important that the game actually plays rather than it remains accurate to the host machine which it came from. So there's only so much you can kind of do with emulators. They are good for testing how your projects are getting on, but it's always recommended to test them on the real machine first. And this has kind of tainted my view slightly of the Wii. It kind of, I thought it was more powerful than that. I thought it could handle sort of drawing large images. So in the end, what I decided to do was to create a stripped down background layer without any clouds here. So you see this is just a static layer, and then instead of having the clouds be part of the background, instead I added them to the sprite sheet as 2 independent tiles here. Mind you, it looks a better effect anyway, so it has actually enhanced the scrolling scene. So that's just one thing I wanted to sort of point out to you there. Be careful with your projects. So let's get into the code now. So how the scrolling effects works. So I have a cloud manager. So what I've done is I defined or I decided that 16 clouds would probably be enough. Could be too many actually, I'm not too sure. And then I decided that I would split the amount of them. So as I wanted to have 2 layers of clouds, one half would be drawn to the bottom screen, or rather the bottom layer, and then the other half would be drawn to the top layer. So obviously to create the layering effects, it's literally a case of the draw order of your images to create the virtual sort of layers. So there are 2 cloud types, so I defined those in here. And then to give the position of the clouds a bit more randomness, at the start of the cloud manager initialize function here, instead of limiting the X position to just that of the display on the Wii, so this define here is basically set up to be the same as the screen width and height, just so that I don't have to type in 640 by 480 every time I want that. By parameterizing these as well, it means you can easily sort of port this to the desktop should you wish to, or another machine with potentially a higher resolution, and you just have to change these values out. Which is why in loads of my programs you'll see that I use these defines as much as I can. That way the code can kind of be not only portable between various machines, but it also allows just one place for these numbers to be changed throughout your sort of project there. So in the cloud manager there, this is basically the width of the screen plus the width of cloud 1, which is the larger of the 2 clouds. And just like all my other projects I do, I always create a graphics define header file and then make a note of the parameters of the various tiles in your scene. I'll get back to the stuff in here again in a moment. The key takeaway in here is there are only a few images. So if you look in here, you'll see we only have 4 images in here, and they correspond to these IDs here. And then as we have a load of tiles in here, as you're sort of constructing your tile sheets, it's best to make a note of where these tiles start. So you'll see in LibreSprite here, it handily gives us the pixel parameters of the cursor here. So hover that to the top left of your tile, and then you can see where it sort of starts. So this coin would start here at 0.32, and then if I press M, which takes you into the where is it? I think it's the selection mode here. Yeah, the rectangular marquee. So M is the shortcut there. So then you can highlight a square over your tile. So you'll see that that's 16 by 16 in size. So then you can make a note of how big one tile should be. So if we come down here, we could add in here our coin sizes. And then another thing to note with when you're doing your graphics as well is where the tile is going to start. So the SpriteSheet obviously has loads of tiles inside it, and the image manager has some handy functions to allow you to add these tiles. So what you need to make a note of is the order in which you add these. So you'll see that the order here is basically the walls first. So I've added the walls here first. So the add tiles function there takes in the start X and Y, the tile width and height, how many tiles across, and the total tile count, and then whether the so the tile count doesn't have to equal the same as the tiles across. So this allows you to for example, with the font set here, so each of these are 16 by 32 in size, and there's 16 across, and then there is 96 in total. So you'll see when we add the if I just side by side things here a moment. So you'll see first off we have the start X and Y position, which is literally here. So you'll see 064 there and 064 here. The tile width and height, so each letter or glyph, if you like, is 16 by 32. So we put in the size here, and then there's 16 tiles across, as you can see there, and then the total tile count is 96. So what will happen is in the image manager there is a rectangle list module which handles basically storing lists of rectangles, and what it will do is it will basically go across collecting rectangles until it gets to the tiles across number 16, and then if this is if you set the next line starts at 0, then it will then jump below and start collecting them from the next line. However, if you set this to false, what will happen is instead of it starting at 0, it will start at the X position that you put in. So for example, we've got these Koopas here. If we had some more of them, for example, say on the line below, then we would have 8 of these in total. So you would say that there's 8 of them in total. So we have 256 by 32 as the start position here, and then it would basically collect these rectangles, and then when it got to the amount going across here, it would then start again at the X position start that you passed in and not 0. So that's how we can create our sprite sheet here, go through, collect all of the tiles together, and then make a note of where each different tile starts, which is what's happening here. So these unique wall tiles here, they have their own sort of tile start recorded for them. However, when you have like a whole group of tiles, then you might want to record somewhere the tile count, which is what I've got here. So the tile start for the explodes is 16. So this first one here is the wall tiles. The second one here is the explosions. In fact, that does not look right. I think it might be 100. Oh, that's fine. That's fine. There are 8 of these. Look. So these are the explosions here. It's where it starts here. So there's 6 of the walls there, and then when you have like a group of them, create like defines for how many of them are. So I usually have the TS for tile start, and then TC for tile count. And then what this allows you to do then is to add both of these together to get the start of where the next group of tiles are. So you'll see here, while these all have individual numbers, all the rest here rely on the tile start of the one before it, and then the tile count of how many types of them there are. And then if you've got like you need to record the size of an individual. For example, here we have the cloud 1 width and height, the bullet width and height, the custom collision size for the player, the bonsai bill, and the coopers and coins here. So that's how the tiles are added for the sprite sheet there. That's how I recommend recording the order as well. This bit here just loads in the various images. So these orders here correspond to these. So the background layer is loaded first. So that's image 0. Then the small font, which is image 1. And then you'll see in here the tiles are added in the load graphics part here for this first font, whereas the sprite sheet is just loaded here as an image first off, whereas the controls sprite sheet here, because all of these images are the same size, we can literally just load them all in one go, which is what this does here. So I'll now get back to what's happening in the Cloud Manager here, now that I've described how the sprite sheet is created. So in the Scene 2D manager now, there's also like a custom blit structure, and the clip to camera is being used now. So there is like a virtual camera rectangle, which is it's not being moved in this case because the background itself is kind of moving around the camera. But if you were to move the camera, then things would be clipped outside of it. So we have a custom structure here for our cloud. All we need is a rectangle which will describe the position on the screen and also how big the cloud is, which will be useful for determining whether it actually goes off screen or not. And then each cloud potentially can have its own speed. And then we also have another variable to record which cloud graphic it is. So we can have either a large cloud or a small cloud here. And then this is just a list of our clouds. So you'll see here in the header file here, we basically lay out a few parameters for the construction of our cloud manager here. And then at the start here, we pass in a scroll speed. So this isn't really used in this demo here. In the next version, part 2 of this, this will come into play as I will sort of introduce different levels, which will just be a case of the display scrolling faster and everything moving faster. So we basically create like a cloud pointer at the start here, point it at the start of our list, and then this Y offset variable here, as both of the cloud types have the same height, we take the first cloud, the height that we have, and then we divide that by 2. And the reason for that is we will, when we give the cloud a random Y position, we basically take the size of the screen here, and then we basically subtract half of its height from that. And what that will do is that will allow a cloud to partly overlap with the top of the screen and also partly be outside at the bottom potentially. So here we're basically creating random positions for our clouds. The X coordinate can be either fully on the screen or partly off the screen. Or, well, fully off the screen actually. And then we give our cloud the possibility of being one of the 2 types here. If it's type 0, which is the larger cloud, then we set its rectangle with the size of cloud 1, and we give its graphics frame the start of the cloud 1 tile. And then if it's obviously the second one, then we do these here. Obviously if you had a load of different clouds, the easiest way would just be to use a switch block to do that. And then we give our clouds a speed between 1 and then the scroll speed. And then we just increment our pointer to our list to go to the next cloud. And then the updates are straightforward. We can literally move all of our clouds, which is what we're doing here. So we move our cloud here by subtracting the speed from the cloud's X position here. We then check to see whether it overlaps with the Sine 2D camera. If it doesn't, then our cloud is off the screen. So what we'll do is we will reposition it to the outside right side of the screen and then give it a new Y position and a new random X position where it's slightly outside of the display here. So you'll see that it's always going to be just outside the right side of the screen potentially. And then we have our two draw functions here where we will draw one half of our list and then draw the second half of our list. And then we basically just create a 2D blit in here, which we basically just reuse over and over again for all of our clouds. So you'll see here we can set two of the parameters for our cloud in here, as they're not going to change. They're always going to use the image sprite sheet as the default image for our tiles. And then this new function I've added here allows you to just pass in the 2D blit, and then you specify the tile, and then inside Scene 2D it will basically talk to the image manager, get the size of the tile in the tile list for that image, ready for when it draws it later on. So that's the clouds there, which gives us our scrolling effect. So now what I will, let's have a look, what was I going to go into now? I think I'm going to go into the sine wave effect and how I did that. So initially I was trying to fill out a lookup table using the sine function, but I was having sort of issues with that, so I thought, well, the quickest way is just create a 2D lookup table, which is what we have here. So all I did to do this is, if I come in here, all I really wanted was the offsets of a circle here, just 1/4 or a quadrant, if you like, of the circle here. So all I needed was to record the Y offsets against the X offsets. So this is basically what I did here. I drew a circle in here, and then all I wanted was this part here. So if I side by side these a moment, so you'll see we just have one part. So -7 is this here. So you see that's 7 in height there. And then we have 6 there, 6 there, and then 4 there, 4 there. So this method, you can use this on any console basically. So if you want to create like a custom sign on the Game Boy, for example, or the Commodore 64 or anything like that, the easiest way is to create a table of predefined values, and these are basically just offsets. And then as you go up here, so when you get to bits like this, you have a 1 offset here and then a 0 here. So every time it doesn't move, that's 0. Same here. And then here you'd have 1 move there, and then you chuck in 3 zeros here. So that there is most likely this one there. So you'll see -1 there, and then another 2 zeros. And then at the top here, the last one, you have 1, and then there's like 7 zeros there. And that's the 7 zeros there. So then what you can do, obviously we need to have our characters go up on the y-axis in this circular motion here. So once you can move them up to the top here, you can then subtract this from them to make them come back down again. So they'd basically come back down here. And then you can reverse the sine again here. So you can have it come down and then go down again here. So when we go up this way, we are basically subtracting from the y position of our character. Then when we go up, when we come to this stage, we just add 1, or rather we flip the sign on this so that it becomes a positive number going the opposite way. I'll show you the thing here. So there's 4 stages. We basically reuse this 4 times to create them sort of going up and then dipping down and then coming out of it. So you kind of have something that looks kind of, if I change the canvas size a moment. We reuse the arc here basically, and then we flip it so that we have the start here, it then goes down, then they come back up. So there's 4 stages: stage 0, 1, 2 and 3. And then you'll see in here, if I open the baddie manager here, you'll see each baddie has the lookup stage variable. So that can be 0, 2, 3. And then we have the lookup table offset. So in that lookup table there are 62 different numbers in here. And once we have this, we can obviously reuse it by multiplying all the numbers in this lookup table by, say, 2 or 3. You can literally increase the speed of the sort of the angles that they'll move, or rather the arc that they will sort of travel through. So it is pretty versatile and fast as well. That's the key thing. So the 62 variables in here. So the lookup table offset would start at 0, which would give us the first one to add to our baddie's Y position. So all what happens is we choose a Y position on the screen for our enemy, say our bonsai bill here, like so. He would start here, and then by adding the offsets to the Y position, you'd then move up. Once the lookup table offset number here gets to the top here, then instead of subtracting, we add instead. And then it would appear to bounce down. And then we reset the lookup table offset number. We're now in stage 2, and we add again, which then brings him down, and then we subtract again, and then he goes up. That's what each of the stages do in here. So in the Y position movement function here, you'll see we have a lookup table offset in here and a stage number, which we take from each of our baddies here. And then using a switch block here, we see what stage are they in. So in stage 0, what we do is we take the number in here and store it in our change variable. And then what we also have is a Y multiplier variable, which is global and private to this module here. So you'll see that this is a float value here. And the reason why I made it a float is so that we can gradually change the multiplier to say like 1.25, 1.5, 1.75, or any number in between there. So we take the number from the lookup table at the baddie's lookup table offset, which can only be in the range 0 to 61. We then times that by the multiplier, which allows us to increase or even decrease the size of the sine wave that they will transit through. And then we use the nearby int command, which is used to round a float to the nearest integer. So we then take the change variable here and we add it to the baddie's Y position. So by adding it, you'll see these are all negative numbers here. So at this stage, this moves them up. And then once the lookup table offset reaches the end of the lookup table, we basically make sure the lookup table offset is at the end, so it doesn't go past the end. We then increment the stage number. So what's going to happen is the offset basically goes through to the top here. It then goes back to the bottom, then it goes back to the top, and then back to the bottom again. The only thing that kind of changes with the stages is whether we add or subtract that value. And this basically gives us a nice way of creating the sine wave movement for the baddies there. And then once we have done this here, we basically pass the temporary variable of lookup, stable, offset and stage back into the baddie here. So the initialize function, all that basically does is it calls the reset function here, and that just basically again, this will make sense in the next video. You see that the reset one takes in a level ID here. The idea will be in the next video that there'll be like a amount of waves that you'll have to defeat, and then it will get more difficult, as in everything will speed up. And then also in here you'll see that although it's not implemented at this stage, there is a fire rate timer for the baddies in here as well. That will obviously be useful in the next one when I give them the ability to shoot back at you. So the Y multiplier just takes in the level ID and times that by 0.2. And then you'll see we have a few different positions where the Koopas can spawn. This was simply done in LibreSprite again as well. So basically just took the height of the screen here and then divided that by 2. And then if you enable tiles here, you can kind of say, okay, I don't want them to be at the top or the bottom, so then I'll have them spawn every sort of 2 or 3 tiles like that. And then that's how I sort of come up with these values here, so that they don't sort of start out of the screen or at the top or the bottom. And then this just goes through and initializes them all here. So all of the collisions basically use rectangles. So we have the rect structure here, and then there is a function here which we pretty much use for every collision here, which is just rectangle overlaps. It just compares one rectangle with another, and if one is inside the other or overlaps, then that just returns true. And that's the easiest way to check for collisions with everything in games. And then there are currently 2 types of these in here, which is what this is doing here. This is just using the modulo operator to take the value of n and make sure it maps it to the range of 2, so it can only be 0 or 1 here. And then another thing that this is doing here is, instead of giving the enemies all of this same in fact, that shouldn't be there. That should actually be the stage. So the idea is that they'll all be at a different stage, so they will all be moving Oh, that's already done at the top there. I don't need to do that. That was obviously an error there. So the idea is they all should be moving in different directions. So they'll all be slightly offset from one another. Let's just rebuild that a moment and see what that actually looks like now, considering it wasn't doing that just before. Okay, what have I done? Okay, so they're bouncing right. I've obviously altered something here. Oh, I must have changed something. Oh, I think it was in here. What was it I changed? Oh yeah, that was it. Need to be more careful. Let's make sure it's back to working again. There we go. So you see here they're all currently at sort of different stages, so the idea is that they all should be slightly alternating their movements, which they kind of are. Every sort of two Koopas, they'll be slightly different, so they'll choose like a random starting position, so they're not always at the same position each time. That was one thing I wanted to sort of do there with that. So at the start here, their lookup table stage will be between 0 and 3, so they'll either move up or down at the start. So it could even be better to let's try that. I think that might work out a bit better. Okay, no, that's not really what I was going for. Anyway, this just initializes them there. Each basically has their collision rectangle set up. So you see this one here initializes our collision rectangle to the Koopa width and height, which again comes back to why it's important to define all these parameters somewhere. And then I've already gone over the move Y position here. So in the update function here, we basically there's a timer in here for when they've basically moved off the screen. it kind of like pauses for a bit. That's what this is doing here. So when they're initialized or reset, the spawn timer here, again you see that this relies on the level ID as well. The idea is that they will also spawn quicker. Some of the parameters here I'll probably have to tweak in the next video to get it kind of working right. So the movement here, basically, if the Cooper is alive, then its X position will be subtracted by the global X movement speed, and then if it goes off screen, then it's set to not being alive anymore, and its count is subtracted. And then if that doesn't occur, then the Y position is moved, and then here we just update the collision rectangle origin with the position, and then this just handles animating the Coopers here, as they all have the same amount of animation frames. That's what's happening in here. And then the draw function, basically it kind of goes the same as the clouds and the explosions. Really, they all have the same sort of draw function, really, where you create like a one blit which will be used over and over again. And then the collision function here, this takes in the a rectangle of an actor, and then if it's a bullet, then the Cooper will be killed, basically. It probably should just be set to do that for everything, really, I suppose. I'll probably do that in the next video here. So you see what actually happens here is the Cooper has access to the explosion manager in its header file here. So if it dies, it can call the explosion manager and pass in its starting position, which will then be copied into a free explosion object, which will then be triggered. And then we also position this Cooper here outside of the screen here to make sure that when the Coopers are reset, it doesn't get redrawn for a frame or two. So that's the baddie manager there. Not going to save anything in there. Could end up breaking it again. So let me see, what have I... Move that one down there. So I've covered these here. So I'll go for the explosion manager now. Basically the a very similar setup to the cloud and the enemies, really. So I decided to chuck in a load of explosions, potential for 24 of them, and then each one will kind of each frame will be in place for like 5 updates here. And then this is straightforward here. You just need to initialize the explosion manager at the start of the game, and then there's the reset function, which is can be called on its own. after the initialize has been done once. And then all you do is once an actor is exploding, just pass in its start position, and then the explosion manager, it has a list here of explodes with virtually nothing in there really. The parameters, it just has a frame and a boolean of whether it's alive or not. So this is basically treated like a cache or a pool of explodes which we can use. You see here the reset function. All it does is go through every one of these, and then as we know they're always going to be the same type, we can literally set each of their blitz to the default here. So set SpriteSheet and the clip to camera. I didn't really need to put this in here. I could have just done it exactly the same as the baddie manager really. So we set all of them to not be alive basically. And then when we need an explode, we have to go through our list and try and find one which is not alive basically. And then what we'll also do is we'll keep track of the frame ID of each of these. So it should only be doing this actually for ones which are alive. So the idea with this is if we have no usable explodes left, then what we'll do is we will just take the ID of the living explodes and the one with the highest frame ID. So in that case, what would happen is one explosion wouldn't get to complete its full cycle. It would just be reused for a new explosion. That's what should be happening here. Let's just make sure I've not broken anything, as I am obviously talking while doing this. There's a chance to introduce errors. I think at the moment there's not enough stuff in the game to probably use all of those explosions up. So that still appears to be working, which is good. So all this does here is it basically gets the ID in our cache or pool for an explosion which is either not alive or has the highest frame ID. So if it finds one which is dead, then it returns the ID of it here. Otherwise, it returns the highest ID number here. So when you call add explode, what will actually happen here is we'll get the ID from the get free explosion, we'll then create a pointer to that explode and take it by the ID supplied. Then we'll put it alive, set its frame to 0, and then copy the X and Y passed in to its destination rectangle as the X and Y, and then we increment our explode count here. And then in the explosion manager update, all we do is we check to see whether the animation timer has expired. If it has, then we go through all of the active explodes and update their frame ID here. And then if it reaches the last frame, then we unalive it. And then the render function is pretty straightforward here. Same as before, we use the add tileblit function here, except we add the frame which the explode has locally to the graphic tile start explodes ID number to give it the correct frame. So that's all of that covered. So I'll now go through the main function quickly, so you see all what's here. So I added in some other stuff here at the start when I encountered my errors previously, where the screen was glitching out when I was doing that other scrolling effect. So I tried adding in this function here, see if this would make a difference. So what this does is it's basically creating like a scissor effect where it should be sort of clipping every image that you draw to the frame buffer, which is the sort of current screen in memory that you are drawing to. So this is using, this here is using the defaults from the default sort of Wii library in DevKit Pro. And then you see here I initialize the graphics here and the SpriteSheet here. So Bonsai Bill here, he has he has a couple parameters in here. He has a collision rectangle here. These are his IDs for using the lookup table. The bullets currently reside in main here as well, and there is an actor structure. I can get rid of this. I was going to try and use like a path list. This was one idea I had, but instead the sine wave code goes better. In the next video I will move the bullets into a bullet manager header and module. So this is just the parts of the bullet here, like, which handles all the code for setting them up. Where you'll see in here, if when each bullet is updated, if it's alive, we check to see whether it's hit Bonsai Bill here, or we pass it to the bullet manager and ask whether it's hit one of the baddies there. Sorry, the baddie manager here, and see whether it's hit one of the Koopas. If it has, then we unalive the bullet here. And you'll see before the main loop here, all of the managers are initialized here. Bonsai Bill's given the starting height of 240. And then the this animation timer here basically just handles our player's animation. Again, I'll put him into his own module in the next video. This video kind of shows you part of the stage for sort of playing around, creating games. There's like a point where you are sort of creating programs where it makes sense to kind of just have things all bundled in together while you are sort of practicing and tweaking a program to get the sort of desired result that you want. And then once you're happy, then you can kind of branch out, add in like a title screen manager, and then like a game manager, which is what I'll be doing in the next video. So this is all of the input controls here for the player. And then if you look down here, there's this bit here is basically for Bonsai Bill again, where he has the same sort of parameters that each of the individual baddies have with regards to the lookup table. Yeah, so that's it for this video. I present you this as it is for you to have a muck around and get happy with all of the stuff in Scene 2D and have a play around, see what you can come up with as it is. So the next video, everything will be sort of rearranged into the relevant parts for it to be a mini game. And also in that next video as well, I will also show you how to add in a sound library as well, as this also feels kind of bare without any sound effects, possibly some music as well. So those will also be added in the next video as well. If you've got any questions about any of this, then let me know in the comments below, and I will catch you in the next video. Thanks for watching.